the combination of virtual reality and eye tracking in unison that makes this a tool. So it's a first for eye tracking as well. About 2 years ago, we started working with Jet2, who had a very kind of forward-looking kind of vision of where this technology could be deployed, and we sat down with them and decided, where can we create a business case? And we focused on pilot walk-around inspections. So pilot walk-around inspections are part of mandated type rating. They are regulatory approved, and they are. And to be honest, I have to admit, I'm not actually originally from the aviation sector. I'm a physicist, and I actually come from working in submarines originally. So
wow, okay, that's interesting.
Yeah, and so I've only really been in aviation for the last sort of 10 years. And so to understand actually some of these use cases, it's a bit of a, I still have some understanding barriers, but what we understood and what we've found is that this use case of pilot walk-around inspection, it requires training or cadets to go airside to have an aircraft available, and actually that's difficult. It's surprisingly difficult, even for a big airline, and actually also they have to be able to train to look for these kind of faults, which almost certainly won't exist on the aircraft that they're looking at. You also have the problem of how do you actually objectively assess somebody's inspection abilities? You can kind of say, did you spot X? But then you're kind of relying on kind of a subjective kind of view, or them telling the truth, or actually, if there's nothing wrong with the aircraft, what would they have noted? So, so actually, this is this kind of combination of technologies, and what we've developed Jet2 and been working with the CAA to get approval is a VR-based training system that replicates at the current point 2 aircraft, so a Boeing 737 and an Airbus 321. And again, this is our naivety starting this process. We thought kind of a small number of faults, but actually this is probably 100 kind of inspection points on these aircraft that we've had to kind of model. So we created these virtual replicas of the aircraft. You put a headset on, you can inspect the aircraft, you can move around. So this is what classic use case of virtual reality. You can bring the big thing into the small space. You can kind of explore and understand and learn. But really crucially, we can build an eye track. There's eye tracking embedded as a COTS, as a off-the-shelf kind of system that HTC make and others, and the system can monitor where they're looking. So they do one pass where they look at they're kind of led and they're kind of shown what they should be looking at, and then they do another where the safety rail's off and they have to do it themselves, and they are the system is tracking where they're looking. We're tracking and differentiating between glances and actually taking information in, because that's obviously something that's quite critical. And our starting point for this was also to go actually and put some eye tracking glasses onto an expert and walk around a real aircraft. And from there, this is the kind of thin end of the wedge into kind of then understanding what competency in these kind of tasks look like. There's one thing to kind of spot the things they should be spotting, but actually expertise probably is associated with things like gaze strategy efficiency. Are they quickly looking at the right places? Are they not randomness? Their eye movements are not particularly random. Are they systematic? Are they effective and efficient? And we can monitor those kind of things as well. So we can give a tool that on one end of the scale, did they look at the right things? But on the other end of the scale, helps us start to understand and piece together over time, because we gather data over time, what competency in an inspection task looks like. So yeah, that's what it is.
That's fantastic. I just want to understand a little bit more about how are you able to accurately map, like you said, the glances or the expert's way of looking, and how many faults or do you have in your model currently for the walk around?
So the way that we would, we have quite a lot of experience in building what we call kind of cognitive task analysis. So we would, and this is from several different sectors. So Cineon, although aviation is our kind of leading kind of vertical, we do work in other areas like healthcare. We've done work on oil rigs and things like that, oil industry. And so we quite, one of our starting points of building a simulation or understanding whether or not a simulation that may exist already is effective is to try and understand what kind of strategies, gaze strategies, or modes of attention a real worker or pilot, whoever it is, might have. So we put them into the real world. We put the eye tracking glasses, so just kind of glasses augmented with eye trackers. They go and do their normal job. We can analyze that. We can look for these kind of trait kind of eye movement markers of competency, recognizing that we don't necessarily suggest that every expert looks the same. People may achieve proficiency and good performance through different means. And then use that as a bit of a baseline to then build a simulation that has what we would call construct efficacy. So it has sort of construct validity. So it not just to kind of the two kind of psychological constructs. One would be face validity, where it looks realistic, which is obviously important in this inspection task. But actually, how do we know that any kind of the training on a simulation transfers into the real world? Well, that comes from construct validity and understanding that people perform in the way that they would out in the real world, in a virtual world or a synthetic world. So we can use a cognitive task analysis with eye tracking glasses to do that, and then understand the utility, and then essentially build a tool around that. The simulations themselves, and this is where we kind of were pretty naive coming into this, not really being kind of particularly technical in terms of understanding every point of an aircraft. Obviously, there's got a lot of things on an aircraft that should be inspected. There's a lot of moving parts. There's a lot of widgets, and there's things that you are just difficult to understand from a layperson. So things in kind of wheel bays where there's valves and tanks and all kinds of things, and recognizing also that there are very clear limitations with virtual reality. So this isn't a kind of full flight simulator. This isn't fully down to kind of one-to-one model of the real aircraft. It is an emulation, and VR has to be optimized for it to be usable and not feel uncomfortable to the user. So there is a halfway house to find. And actually starting this project, one of the big risks was, could this work in VR? Can we get a high enough degree of kind of reality, like stimuli density, without just essentially breaking the system and make it unusable for the user? And luckily, we found that yes, we could get to that point. There was a sweet point. So we're talking about something like roughly 100 kind of inspection points in an aircraft, and these will be things from maybe they're just kind of little images they're looking for, things that have been left on, or maybe they're even things like a kind of inner tube or on a dial. So there is quite a high degree of kind of fidelity needed for it to be accurate and valid, I think. So it's been a lot of work, if I'm honest. We probably started development, came up with the idea about 2 years ago. We really got into it about 18 months ago. It's probably been the last 12 months of really a dev team building out these models, because you can go out and buy 3D models of aircraft quite easily. You can put those into your simulation, but they won't have all the little bits that are required in an inspection.
Right.
So that's been a learning process for us. Certainly.
So you're close to certification now?
So we are very imminent. So we've been given kind of outline approval as other training device as an alternative means of compliance by the CAA. We expect the approval to go through in the coming weeks. So, and at that point it will be, and I keep saying this and I had to double check, but I'm sure, the first VR training system approved by the CAA for UK use. But actually, the point I would like to make is that I think where it's different to other VR training systems that may have been approved is that actually it's really the eye tracking that makes this that really provides utility of this. So I think both technologies, it's the combination of virtual reality and eye tracking in unison that makes this a tool. So it's a first for eye tracking as well.
Fantastic. And what will the years to come bring in terms of your offering for our industry? So
we see this tool as being very much the thin end of the wedge in terms of the technology. So we use an analogy that, in fact, it's a military analogy that we've kind of pinched, and in fact the military suggested we use it when we talk about this technology in their space. And it's this analogy around crawling, walking and running. Where is the technology currently? It's like in the kind of walking, to crawling to walking. So we would say this is the kind of the thin end, the easier application. So we know we can build 3D models. We know they can be accurate and realistic, and people can use them. We know the eye tracking is effective at monitoring what people is looking at, monitoring attention. It can differentiate between a glance. It can understand, has someone taken in that information based on data that we know from research. Where can we now go with it that is more into this kind of walking to running phase? And where we want to go, and where we've been working in parallel to this over the last few years, is very much in the evidence-based training side and the CBTA. So this is how we can use technologies like these to understand and objectively assess and feedback to assessors and instructors pilot competency. and particularly the kind of human factors-based pilot competencies that are very difficult for human beings or an instructor sat behind a seat on a simulator to kind of effectively and objectively assess. And we are on that journey at the moment. We're working with some airlines currently and with the military. And the kind of point that we're at is that we have some tools that can, for example, again, understand where people are looking. Are they monitoring fuel in those kind of obvious kind of things? Can we look for evidence of gaze strategy that we know to be present in either trained, so pilots are trained to do LOIs, for example. Can we see an LOI? Can we automatically detect an LOI? Actually, can we also see the kind of gaze strategies and the efficiencies associated with expertise? So we've been published in things like the International Journal of Aviation Psychology, demonstrating that experienced pilots, as you would probably expect, have very efficient gaze strategies and very systematic ways of kind of getting information from their surroundings. A system can detect that in a way that a human being can't really monitor. The running end of this is the understanding of the kind of psychological concepts around, as I mentioned, the kind of stress, anxiety, workload, fatigue, and how these relate to competency, how these can be mapped across competencies. And we had this kind of idea, which was wrong a few years ago, that we would use these to kind of essentially replace an instructor and create like an automated assessment system. Actually, the technology isn't there, but it is there insofar as being able to give an accurate and a useful tool to enable instructors to make an objective decision based on things they just can't know. They can have a good feeling about, and they can go back and look, but they can then look into the data, and the data can be quite clear. And also, once we start gathering these data, and as you walk around the kind of exposition hall today, you'll see tons of simulators that gather tons of data. Once we start generating that data, and we can actually apply these kind of processes to it, then we will start to build up a really good understanding of the kind of monitoring piece and the competency piece in years to come that I think will be really effective. So that's where we're heading, and that's the kind of journey we're on. And we're really, I guess the ask from us is we're looking for data set people, pilots, airlines to work with to kind of continue that.
Fantastic. Toby, it's been such an insightful conversation. Thank you for all the insight you provided. We can talk for hours on the topic,
Yes,
but we've got to let you run off and meet people that you need to meet. Thank you so much for making the time and joining us
Thank you very
on
much.
this discussion.